Hi, this is Matt with AppliancePartsPros.com. In this video, we're going to show you how to troubleshoot the top 6 reasons why your refrigerator won't start. Stick around to the end of the video for an important tip that can help save you money. But before we begin, we're going to make sure the appliance is unplugged or the circuit breakers are off so there's no chance of electrocution. Also make sure you turn off the water supply underneath the sink. First thing we're going to check is the run capacitor. It's what helps the compressor run after it starts. The run capacitor is a device that supplies extra energy to the compressor to allow it to run as efficiently as possible. It supplies a boost anytime the compressor is running. If it's failed, the compressor may start up, but it could draw higher than normal amperage and cause the compressor overload to kick in and shut the compressor down. Some older refrigerators will have a start capacitor that stores electricity and releases it when the compressor needs to start, but then shuts off once the compressor is up to speed. Capacitors are usually located behind the access panel at the back of the refrigerator, but some are located behind the main control board access panel. If your refrigerator seems like it's not starting, it could be that the run or start capacitor has failed and the compressor isn't getting enough electricity to start or to continue running. Once you have access to it, depending upon the style, you can simply pull it off the start device or use a small flathead screwdriver to remove the wires. Then take it out of the fridge to inspect and test it. If it has any swelling or looks like it's been leaking, then the capacitor is bad and needs to be replaced. If it looks okay, then we'll have to grab the multimeter and test it. So set your meter to ohms. Our meter automatically detects whatever ohms are coming in, but you may need to set your meter to read the proper ohm level. Before testing, we need to discharge the capacitor, remove the wires, and using an insulated screwdriver, lay the shaft across the terminals. Be careful not to touch the metal part of the screwdriver as you do this. Then touch a probe to each terminal. The ohms reading should go up and then drop back down. Then reverse the probes and test it again. It should do the same thing. If the reading doesn't change for either one, the capacitor has failed. If you have a metal capacitor, you'll also need to check to see if it's shorted to the casing. So touch a probe to one of the terminals and the other one to the casing. Then move the probe to the other terminal. If you get a reading for either one, that means the capacitor is shorted out. If any of the tests fail, then the capacitor is bad and needs to be replaced. If you need to order a part, simply go to AppliancePartsPros.com and type in your model number. Find your part on the easy-to-read diagrams and match it to the number below. Click on the part if you want to see more pictures of the item or watch its repair video. You can also scroll down to see DIY stories from customers like you, or ask a question in the Q&A section. Once you're ready, you can add the part to your cart. It's that easy. Most orders will arrive within 2 business days. Next, we'll look at the cold control. It's the control you set the refrigerator temperature with. Cold controls have been used for many years. They have a shaft for the knob to mount on, a sensor bulb that senses the temperature, and a body which has the contacts inside of it. Most also have 2 wire terminals. They're usually located on the control panel, mounted right behind the control knob. If your refrigerator won't start, it could be that the cold control is bad. The contacts inside the cold control are open and closed by the pressure created in the sensor bulb. As the refrigerator gets warmer and colder, the fluid in the sensor bulb expands and contracts. If you notice that the compressor isn't coming on and the fridge is getting warm, it could be that the contacts inside are stuck. As a simple test, while the refrigerator is running, you can try knocking on the area around the knob to see if that'll break the contacts free. If it works and the refrigerator starts cooling again, that's a good indication that the contacts are sticking together and the cold control needs to be replaced. If it didn't work, make sure to unplug the fridge again before you move on. In order to test the cold control, you'll have to open the control section and remove the wires. Depending upon the design, you may have to remove the knob and screws to get to the wires. In order to see if the part can carry an electric current, we have to test it with a multimeter set to continuity. Once you have it set, touch the probes together to make sure it's working. You want to make sure the cold control is in the off position. Then touch a probe to each terminal. It should not have continuity in the off position. Then turn the control on. It should have continuity when you have it in the on position. If the control fails the continuity test, it'll have to be replaced. The last part of the control to check is the sensor bulb. Over time, they can rub against something or just fail and start leaking. If you see any damage or indications of oily residue along the bulb or where it mounts to the body of the control, then it'll have to be replaced. Now we need to look at the defrost timer. It controls the defrost cycle of the refrigerator. The defrost timer is made up of a motor, gears, and contacts. It switches the refrigerator between the cooling and defrost cycles and helps keep the evaporator free of ice buildup. They have a set number of hours for cooling and minutes of defrost. As an example, this one will run for 8 hours and defrost for 30 minutes. Defrost timers are usually mounted in the control section of the refrigerator, but on older models, they may be behind the kick panel. If your refrigerator compressor won't start, it could be that the gears or motor inside the defrost timer have failed while in defrost mode, preventing the compressor from starting again at the end of the cycle. In order to check and see if the timer motor is advancing, you can mark the shaft of the timer and then check later to see if it's moved. If it didn't, then the motor or gears have failed and the defrost timer will have to be replaced. If you think the motor or gears failed while it was in defrost, you can temporarily turn the power back on, then manually advance the timer out at defrost. If the compressor starts up, then you'll know the motor or gears did fail and you'll have to replace it. The other way it could have failed is that the contacts inside the timer have gone bad and they're no longer sending power to the compressor. To test this, turn the center shaft all the way around again. If the contacts are bad, the compressor will never come on and you won't hear it shut down for the defrost cycle. If you determine that the contacts have failed, you'll have to replace the timer. Once you're done, make sure you unplug the refrigerator again before you move on. Next thing to check is the start relay. It sends power to the start and run windings of the compressor. Start relays have been used for many years. They send power to the start and run windings of the compressor and then cut the power to the start windings once the compressor gets up to speed. Compressors are usually located in the back behind the access panel, and the start relay is usually mounted on the side of it on the pins. It may or may not have a cover on it. If your refrigerator won't start, it could be a bad start relay. A lot of times you'll hear a clicking noise coming from the relay if it's failed. In order to inspect it, you'll have to remove the cover if you have one, then use a small flathead screwdriver to remove the wires and pull the relay off the compressor pins. If you have the type of relay with the coil on top, they have a plunger in them, so they'll rattle some. The other types of relays may have a very small rattle as the discs move around, but there should be no loud rattling. Also check for a burnt smell, a melted body, or any small particles falling out as you shake it. If the relay has any of these physical signs of damage, you'll have to replace it. If you're still not sure the start relay is bad, then we'll have to test it for continuity. If you have the older style relay with the coil on it, you'll want to test it with the coil pointed up. Stick a probe into each pinhole on the relay. It should have continuity like this, but if you turn it over, it should lose continuity. On the newer style relays, you don't have to worry about its position. Just stick the probes in the pinholes on the back. It should have continuity. If the start relay fails any of the continuity tests, it'll have to be replaced. On rare occasions, the disc inside the relay may have failed in such a way that it gives you a false positive for continuity, but won't allow the compressor to start. If you think that's the case, you want to verify that the relay is getting power. Usually you can hear it clicking, so you know it's getting power. Then you want to check your compressor windings to see if the compressor is bad. This is only for the older style compressors that use a relay or start device, not the inverter or linear styles. First, we need to check to make sure the windings haven't shorted to ground, so set your meter to continuity again. We want to touch one probe to a spot on the compressor that's clean and not painted, then touch the other probe to each of the 3 pins. No pin should have continuity. If any have continuity, the winding is shorted to ground and the compressor is bad. For this test, we need to set our meter to ohms. We need to test the compressor windings to see if any are bad. Usually the pins that are side by side are the start and run windings, and the upper or lower pin, whichever you have, is the common pin. As you do the tests, you should write down the ohms readings. First, we're going to touch a probe to the common pin and the other one to the left pin. Write that reading down. Then move the probe from the left pin to the right pin and write down that reading. Then take the probe off the common pin and test the left and right pins. Write down that reading. Now add up the two smaller readings. It should be equal to the larger reading. Due to all the variables, it may not be exactly the same, but it should be close. If the readings are way off, then the compressor is bad. If you have power to the relay and the compressor is good, then the relay or overload device is bad, even though it originally tested good. As always guys, hit those like and subscribe buttons now to help support us making more of these videos. Now we need to look at the compressor start device. It starts and protects the compressor. The compressor start device is made up of the start relay and overload protector. It provides power to the start and run windings of the compressor. In addition, it cuts power to the start windings after the compressor gets up to operational speed. It also interrupts the power to the compressor in the event that it overheats or overdraws power. The compressor start device is located behind the access panel. It's mounted on the side of the compressor on the pins and may or may not have a cover on it. If your refrigerator won't start, it could be a bad start device. A lot of times, if you hear clicking as the compressor is trying to start, it could indicate that the start relay has failed. If it's not making any noise, it could be that the overload protector has failed. You'll have to remove the cover if it has one, then use a small flathead screwdriver to remove any wires and pull the start device off the compressor pins. Depending upon your design, it may be easier to pull it off the compressor and then take the wires off. Once you have it out, you can inspect it. The start relay may have a very small rattle as the discs move around, but there should be no loud rattling. Just like before, check for a burnt smell, a melted body, or any small particles falling out as you shake it. If it has any of these physical signs of damage, you'll have to replace it. If there are no indications that the start device has failed, you can check it for continuity. You'll have to test the start relay and protector separately. There are usually 3 holes on the backside of the device. The 2 lower holes next to each other are usually the relay. Stick a test probe into each hole. It should have continuity. The upper hole is the protector. Stick one test probe into that hole and then touch the other probe to the protector's wire terminal on the other side. If any of the parts do not show continuity, the start device is bad and needs to be replaced. The start device has a relay built into it, so just like the start relay above, it could read a false positive. If you think that's the case, you would have to verify the power and test the compressor, just like in the start relay section. On newer start devices with a circuit board inside, you can't test for continuity. You can try to smell the start device to see if it smells burnt inside, or open it up to inspect the board for any burnt parts or defects. Check the overload protector in the same way as a regular start device to make sure it's good and make sure the power is being sent to the compressor. Just like before, you should make sure that the start device is getting power and that the compressor checks out okay. If so, more than likely the board in the start device has failed and will need to be replaced. Last thing to check is the main control board. It sends power to the compressor. The main control board collects all the data from all the sensors and switches of the refrigerator and controls the various functions, including the compressor. They're usually mounted behind the control section in the refrigerator, the dispenser control, or on the back wall of the unit behind an access panel. If the refrigerator compressor won't start, it could be that a relay has failed and power isn't being sent to the compressor during a cooling cycle. Due to all the different designs out there, we can't show you how to test them all here. You'll have to get the tech sheet for your model and run the diagnostics. In this example, you'd have to use the compressor condenser fan test. Your sheet may call it something else, but if the board fails the test, it'll have to be replaced. Now here's that money-saving tip we mentioned earlier. If your freezer compartment isn't getting as cold as they used to, and your ice cream's getting soft, it could be that your condenser coils are dirty. Dirty coils can cause the freezer to run warmer than normal if the condenser and other components are covered in dust and pet hair. Dust and pet hair can insulate the coils, preventing them from working efficiently. This can also make the refrigerator run more and cause wear and tear to those components. Keeping the coils clean can improve your refrigerator's efficiency by 30%, so doing this can save you money on your electric bill and future repair costs. In order to clean them, you'll have to pull the refrigerator out and remove the rear access panel. Then carefully clean the coils. Keep in mind that some may be accessed from the front. You may have to use a condenser cleaning brush to reach in there. Also, while you're back there, clean the compressor, condenser motor and fan blade, and wipe down everything else. Be sure you're careful not to damage anything, and make sure you do this at least once a year. Once you take care of the problem, you can plug the appliance in, turn the water back on, and take it for a spin. Thanks for joining us for another troubleshooting video brought to you by AppliancePartsPros.com. Remember to hit the like and subscribe buttons now, and if you have any questions or want to share how your repair went, leave a comment down below.